analyzing the Charlottesville bus system, understanding its players and its users. We're also looking at the sustainability of the system, using a cradle-to-grave thought process and taking into account externalities of the system. One of the first tools that we looked at to analyze the system was a life cycle assessment. This is a methodology for understanding the environmental impacts associated with all stages of the life cycle instead of focusing on one piece of it. And the flows in the system are raw material inputs that undergo processes. In the CAT system, this would be vehicle parts, fossil fuels, roadway materials, and building construction materials. These functional material units allow us to normalize the effect of different processes involved in bus infrastructure construction, operation, and maintenance across one unit, and then compute the aggregate effects of the overall system within its boundaries.
So specifically in our LCA, we start with resource extraction. So that's primary fuel and material extraction. That includes processing it, distributing it to local fuel stations, as well as vehicle manufacturers, transporting the fuel to the point of vehicle manufacturing, and then also the point of sale. So in that case, that'd be the Charlottesville bus headquarters, where the buses actually fill up gas. During fuel production, there is a significant amount of emissions created during fossil fuel processing, and also during transportation of that fossil fuels. During construction, you also have more emissions. During roadway and station construction, lighting and signaling implementation, parking lots, and also control system development. So that's like the computers that are used to manage the bus system. And then finally, ongoing operation and maintenance costs and processes that also contribute to greenhouse gas emissions, such as bus maintenance, battery and tire replacement, roadway and station maintenance, and also renovations.
Looking at assessing the impacts of the system, there are some primary effects and secondary improvements from the transit system. There is a reduction in car ownership levels and a transportation mode shift. And these effects cause secondary improvements such as more walking and more bike lanes towards these CAT bus stations. There are also some system players that we're going to look at. The major players include the transit system users. This includes UVA students and the general Charlottesville community. They include the resources used. These also include materials to manufacture and maintain the vehicles and the physical building infrastructure, as well as the fossil fuels used in all of these processes. Also, there's operation and management. This includes local government, the payment system to collect the fees, traffic management, roadway management, the drivers and operators, and the CAT and Translog apps themselves. Finally, there's also the bus routes. This includes the routes 1 through 11, which are paid, the CAT system, which is also includes a free trolley, and then the UTS bus system, which is free for students.
So one way to analyze the overall sustainability of this system is by completing a LEED analysis. LEED stands for Leadership in Energy and Environmental Design, and it is a green building certification program that is used to do basically just that. The system is in order to make sure that new projects or like construction projects specifically that arise meet specific sustainability standards, and there are different certification levels. The certification level that the Charlottesville downtown bus transit system received was the LEED Gold. So the categories that it was analyzed under are sustainable sites, water efficiency, energy and atmosphere, material and resources, indoor environmental quality, and innovation. And each of these categories has specific tasks, and the more tasks you complete, the better the certification is. So this system got 41 out of 69 tasks, which is what enabled it to receive the LEED Gold certification.